Using the laws of Boolean algebra evaluate, we are given our expression here, which is our expression is A, B, C, that is not C, D. We add A, B, C, D. We add A, then we have not B, not C, not D. We add not A, that is not A, not B, not C, and not D. And lastly, we add A, not B, not C, and we have a D. The D is not complemented, so C is the only complemented there. So that is the expression. Then we are taught to use the Boolean laws. These are the laws. These are laws that you should have read and known. For example, laws like complementation laws, where we say A or not A, we get a 1, and many others. So we shall be using such laws here to simplify our expression. So to start, very simple, you just play about with which terms are common in which expressions. You factor out, you check whether there is a law that you can apply. Then at the end of it, you will find yourself simplifying the expression. So for example, when we consider this term and this term, we can apply this law because we have a C here which is complemented and a C not complemented. So we can factor the term which is common, which is MBD, and we have C, and we have not C, and we have C. These two will give us a 1, meaning this is MBD times 1, which gives us MBD. So the new expression will now, when we add these two, A, not B, not C, not D, we add not A, not B, not C, and not D, and we add A, not B, not C, and we have D. We have the new expression like that. Considering the expression also, when we look at this term and this term, we can apply the same law because our A here is not complemented and the A here is complemented, and the rest of the terms are common. So we can factor out not B, not C, and not D. Then we have our A and not A, which will give us 1, meaning we shall have the expression as not B, not C, and not D. The new expression is now ABD plus not B, not C, and not D. Then the last one is A, not B, not C, and we have D. At this point now, we have a law that is called absorption law, which says, for example, if we have A and B and we add A, the final expression will be B plus A, whereby we absorb the A which is complemented. So in this case, we can factor this expression as we have this expression this we add to, when you check the other terms, this term and this term, AD is common. Then we have we have the expression b plus b negated c negated. So when you compare this expression and this expression, you'll find that they are similar, where now this a represents this b, and our a complemented here represents the b complemented here. Then we have the c complement, which represents the term b here. So at this point now, the value that will be absorbed is this b complement. So this one will be absorbed. So the expression will remain as not b not c d plus ad into b plus not c. So now after that, you have to open the brackets. So the final expression will be, this is not d, will be not b not c and not d, or a d b after you multiply out plus a d and not c. So this one cannot be simplified further than that, and it becomes our simplified expression when using the Boolean laws that are applicable, as we have seen.